user group a couple weeks ago. I'm fine giving solo. Tanner Blair, he's a senior R&D systems engineer at NI. He was in systems engineering for a few years, while I was there for several years, and we were together there. In this last year, I left NI and came to Indigit, where I am now. Even if he doesn't show up, Tanner fully endorses this message. So, yeah, let's use his credibility of not mine. So we're going to talk about sharing LabVIEW code. I have something particular in mind, and hey, all right.
You can start now.
Okay, ready to go. Is there anything you want to add to my introduction of you?
My name is Tanner Blair.
Give you a mic here. Here's a table.
I don't know what he said, but I approve of all of it. So.
That's a lot of trust. Okay. So this is for a specific audience. Let's see if you're that audience. Practice. Everyone put your hand up. Just one, not two. Come on. Okay. We're going to be participatory here. So, yeah, you can put them down. Who develops with LabVIEW? That's most of it. Who uses primarily not NXG? That's me. Who uses NXG a lot? We use it for pieces here and there, but we typically deal with big systems, and it's not quite ready for us yet. Who works well with others? Well's not up there. Who tries to work well? Doesn't try to work well? Yeah, okay. Or maybe you develop more than one project on a given LabVIEW install. Maybe you would like to share code between projects and be faster, more efficient, better. That's me. You use Git or some other source code control. Who likes Git? Do we have any SVN users out there? Perforce? Any others? Carry on. Okay. Okay. There are some of you who might not have raised your hand, or raised your hand because your neighbor did, but for whatever reason you're not using source code control. We need to have a heart for a second. You need to tune me out for the rest of the hour. Find something like a Git tutorial. Go through that. You will get far more out of it than listening to me or Tanner for the next hour. My favorite Git client is SourceTree from Atlassian. And you can find Git tutorials all over the place. There's some great ones out there. GitHub and GitLab have great ones. Gitkraken folks, I think, have a decent one. And I haven't looked any more recently than a few months ago. But there's a better Git tutorial out there than I can make. I'm serious. It's fine. You can leave. You can clock out. You can stay right where you are. But do that rather than listen to me. Yeah. So let's lay the groundwork. We're going to just talk about a few things here. I'm going to say the word library. And what I mean when I say library is not this. This is a stack of books. This is a stack of books on a shelf, and this is a stack of books of Congress. And this is an LBlib or a LabVIEW library. Library is not these things. Library is something specific. I'm making my Bible share. Sorry. What is a library? It's a set of related code. Can it be Fortran? Can it be C? Can it be a driver? Can it be some special signal processing on FPGA? Can it be a reporting library to make my life easier generating Excel reports? Yes, it can be any of those. It's generally self-contained. A good library contains just the things that do one thing well, but it sometimes depends on other libraries. It's not just different pieces of a project. The idea is to reuse things across projects. Generally, that makes a good library. Also, something about a library is that you have one person that makes it and another person that uses it. There's two roles to a library. Now, it may be you may be in both of those roles sometimes, but there's two roles associated with library. It is implementation agnostic. You can use all sorts of tools to package, to wrap, to ship your library. And it is relatively static, ideally. It's not changing every single day, unlike the repos of your projects that you're actively developing on, right? But it also is not immutable. It needs to change over time for updates, feature adds, bug fixes, etc. Any questions so far? Anyone disagree with me? Okay, you can stay here. So, is this sharing code? If I hand you an exe?
No.
No, why?
It's binary.
It's a binary. I'm going to call this an artifact. This is something we take code and we do something to it and we get something else. Hey, we can run this. Great. But this is not code. I don't give this to a developer. It runs. How about a plugin module? I have this great plugin architecture over there, and I can create a plugin and I can throw it over there and run it. So this plugin. Is this sharing code? No. I'm hearing some no's. You're right. It's an artifact as well. It's a built something that comes from your code.
It could be used as a VI.
You can use a VI. It's possible. Okay. Yeah. So something I'm shipping to an end customer. I'm going to say no. End customer is going to hopefully run something and do something. They're not going to code.
I'll get sassy and say that you're not intentionally sharing the source code. You might accidentally be sharing your source code if you didn't do a good job of packaging, but you're not intentionally sharing that source code.
Yep. Your operator who's pushing buttons and trying to, on the factory floor or whatever, they don't care what's going on in the source code. They're not going to want to change it. They just want to run it, right? Yeah. And how about something that goes to, something that goes to a developer? Is this code sharing? Something that I'm going to give Tanner or Tanner's going to give me so we can develop on, right?
No.
Tentative. I made you nervous here. Yes, this is sharing code. When you're
Not if you give them a tool. I mean, it depends on what you can give them. You can give them an EXE and say, we'll do some of these things.
fair point. What I'm getting at here is the recipient is a developer who's going to develop with it. That's what I'm getting at. That's what code sharing. That's what I'm getting at. We're not giving it to someone who's running it. We're giving it to someone who's developing it. How about on your machine, on any Windows machine, you'll find the one particular obscure Windows blah 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 whatever DLL. It's part of an operating system. Maybe those are functions you can call into. It's not really a library. You can sort of develop on it, so you can call this gray area. But I'm going to say it's sort of not. How about something my buddy made that takes data I give it, it spits out a nice fancy PDF. Maybe it uses something under the hood. It's a DLL. Is that code sharing?
You have the header file and the documentation, you might use it.
Yeah, if it comes with header file and documentation, if it's meant to be consumed to be written code, if it's meant to be consumed by a developer, I'm going to call that code sharing, right? Why is plugin not sharing? Am I giving a plugin to someone to develop on top of it, or am I giving that plugin to plug it into a system to run it? If it's meant to run something that's not, that's an artifact that's going to run. That's not code sharing.
Isn't that what you just said your DLL was? I can't complain, I'm not understanding.
I think that if your plugin was meant to build on top of like a class that they could override, then yeah, that would probably be code sharing. If it is, I guess I can see what you're saying. If it's a plugin that you plug into an executable, then maybe not.
We use plugin in a couple of different ways. So
Yeah.
this is why we're doing this. This is what I want to make clear. If I'm going to put my code in something to give to a developer who's going to build code with it, that's code sharing. If I'm going to put my code in something that's going to get loaded and run on a machine, that's not. That's not code sharing. That's distribution of things that go into EXEs. of artifacts. How about a library? Yeah, okay. Cool. We all on the same page? Right, let's go. So, stating the problem clearly. We've got a library from the maintainer to the user with as little headaches as possible, right? It's not that hard. It's really easy, right? I mean, so we've identified the two roles, right? But we need to break it down. So let's talk about the criteria and list out the different things. A lot of us have been in the LabVIEW world for a lot of years. There's a lot of aspects to this we need to consider. So first off, is it built or not? Is there a build process on this thing? I'm going to put my code in between the maintainer and the user. So the maintainer cares most about this more than the user. The user is going to receive a thing, whatever it is, package, whatever. They don't really care if it's built or not. There can be benefits to come along with building something, but hey, if I can get most of those benefits without the build process, that's great. The build process means every time someone makes a change to that library, they either need to set up the build chain, read a bunch of documentation, figure it all out, go through it, or even to maintain some sort of build server. And who really loves maintaining build servers? Yeah. Welcome. I think I have a build server for you to help me out with. Yeah, so I want to do as little bit of this as possible. That's work that if I don't need to, I'd like to. This one.
But if you are purposely making the library for code sharing developers, then it's better to be built automatically so that those developers have the confidence that this is properly maintained, et cetera, et cetera, et cetera.
Can I restate what you're saying? If you are building a library to share with developers, it's a good idea to have a good build or CI chain around it so that it's well built, well maintained, well integrated code, maybe well tested.
Correct.
That's fair. And a good CI, good process around code tends to make a good library. But do I want to be constrained to have to build something in order to distribute a library well?
I'd love to be out of that.
Love to get out of
I see what you're
that aspect of
doing
it,
that.
I'd love to get rid
If
of.
I got into the library, I have to do that if I want my developers to like me.
Yeah.
And I wish I didn't have.
Rolling on LabVIEW developers, I definitely do that. Oh yeah, I made a sweet library. Here's a bunch of C++ source files, go nuts. And you're like, okay, well this is not, what do I do with this? Where do I put it? How do I get it in my code? Yeah.
Is it a fair summary to say that the purpose of the build process is to isolate the user from developer churn?
Is it fair to say that the build process is to isolate the user from developer churn?
Or say distribution?
Distribution?
The purpose of a distribution by virtue of the build process is to isolate the end user from developer churn.
What version of the library?
Right. So
Not necessarily, and we're going to come back to that. Versioning is definitely important. We want that. A build process can help regiment that, but the build process is something I like to get rid of. So we're going to move on. We're going to get back to it. This one I call sticky. I didn't have a great word for it. Tim didn't really like it, but we didn't have anything better we came up with. If I have a structure that I put my code in, and I put a VI in, I'd like to be able to, as a maintainer, if I want to in the future, pull that VI out. There are structures in LabVIEW that make things really weird when you put a VI into it. It cross-links it both directions. It makes it so you can't remove a VI. Things like LLVs or VLibs get weird in these ways. When you have multiple maintainer developers, things like that cause cross-linking issues in your project, depending on how you check things in. It creates headaches. So I want few headaches. I would like it to not have this. I see some nodding heads, so makes sense. Okay. Private scope. I'd love to be able to have privately scoped things in my library. That is a very useful thing. Does everything need to have private scope? Not necessarily, but when I need it, I want it. Maintainer and user both care about this. As a user, I don't want a library with a bajillion functions and I don't know what to use, right? I want a nice clear API, a clear way to discover that API. Palace can help with that, but we can go back to that. And yeah, we'd like to have this. Namespacing, it would be great to be able to namespace libraries. We have a transition point here. I don't remember where it was.
Yeah, you're doing great.
As long as you say, I approve of this
Yes.
at the end,
You need
we're
to
good.
water or something, you let me know.
Oh my goodness. Yeah, I want to be able to namespace things. Not necessarily because I want to name every VI run, but has anyone ever had a problem when they loaded up some code and had a name collision? That was a bad day, wasn't it?
Any Veristan developers in the room? Yeah.
You're working with a code base and you don't know what names are in there, but you just can't collide with them, or you don't even. Yeah. This is something that we need. Okay. Can I give my library a version number? And this comes to being clear to your users about what version it is, what's going on. Yes, we need to be able to strictly version our things. This needs to be a first-class feature and in your face part of getting any library. You need to know that you're getting a version of a library, right? So we need this. Oh, here we go. Is this, you want this mic here?
To be quite frank, I think this is the transition point where I give it back to you here, so. So I think you should go for it.
Told you to warm up around. I can talk a lot about that.
That's called a bad development.
How many times have you picked up a new project either because your buddy was developing on it and you're coming out of the project, or you're responding to someone's plea for help? Help! This thing is broken, I need you to fix it. And you load this project up, and LabVIEW gives you this. What VI is that? Where is it from? Is it from a driver? Is it from VI package? Is it from VI package manager? Is it from IDNet? What is it? Where did it come from? What version is it? You've never lost half a day from one of these trying to get up on a new project. Yeah. Cry on your neighbor's shoulder for them. Yeah. Okay, so it's almost 2020, guys. Can we find a way around this? We've lost so much time to this. I'm going to call this a manifest file. Does this tool to distribute libraries put some record of it, of what it is, where it came from, what the version is, into my project so it's traceable? I think this is a must. Let's get rid of this problem, guys. We're powerful, we're engineers. Let's solve this problem. Let's make it go away. So I'm going to call this essential. If there's a tool out there that does this, let's do it. Recursive dependency resolution. If I pick up package A, it depends on B and C, whatever. It finds them, it brings them in, picks the right versions. Cool. All right, I want this. Okay.
Non-controversial, right? I'd like to be able to see it in your project.
In a nice way, maybe, yeah. Cool. What projects can see the library? Consult a lot of things. A lot of things have global scope. Has anyone ever realized after they shipped a product and tried to install it on another machine, shipped a project, that you had dependencies in there from things you didn't mean to because they were in your palettes? Or other things could see it? Or your quick drop was loading millions of VIs from other things you didn't really need it to? Yeah, I would like to be able to limit the visibility of libraries into the projects that matter.
How many of you guys have that build server we were talking about earlier? Have some sort of continuous integration server set up? Okay, well, one guy. Well, we have this terrible problem where if we build all these assets, right, and we have libraries we use to build these assets, but I don't know, especially if the thing's working on an older version of a library, my motivation for upgrading and then revalidating every plugin I've ever made is pretty low. So when I'm stuck, I end up stuck on version 2, even though there are features in version 3, because I can't, if I build new plugins on version 3, then I have to change the version on the build server, and then all the old plugins that use version 2 are now forced to use the copy in VI Live, that's version 3, and so now I have to revalidate entire software stacks because I wanted like the one extra function they added in version 3. Or, quite frankly, just not use version 3 ever, right? So this is a huge pain point. It'd be really nice if I could say, this project uses version 3, these other projects use version 2, and this project can see version 3. These other ones don't even know about it. It's not in VI Live in this global dictionary, right? Well, then kind of back to the manifest file thing. It'd be really nice if I could say explicitly, this one's using version 3, that one's using version 2. Yeah.
Okay, so since I've talked a lot, can you sum this up in one slide?
Yes. All right, you guys ready? This is my whole point being this room. You ready? Ideal code sharing tool. It's not built. By that I mean, sure, it's distributed, but we're not going to run it through some sort of compilation process, right? It's not sticky. If I put it into something, I can get it back out. If I drop a VI, it's not going to tell me it can't find the library. Private scope, preferably yes. It'd be really nice if there was secret stuff inside of it that I could not have to worry about trying to support because someone found this function 8 layers deep. Namespacing, it'd be really nice if I didn't have to worry about naming collisions, and I can do things like dynamic dispatch inside of my plugins. Versioning, obviously yes, right? I want to know whether or not I'm using version 2 or version 3. A manifest file, I want to be able to explicitly say whether I'm using version 2 or version 3. Recursive dependency resolution. If A depends on B and B depends on C, then A depends on C. And that's patently obvious. We should have that baked into the architecture so I don't personally have to worry about it for the package mechanism. Can I add it to a LabVIEW project? That's my primary development tool. I want to be able to see it there. And install scope, I want to be able to use different versions of the same library between different projects, right? Okay. So what's out there? I'll take this for a while.
Go for
I
it.
do think you did my list.
Yeah, so how are people sharing code today?
Yeah. So I'll walk through some of the NI technologies. So when I say bad things about them, at least they came from NI and not from InDigit, right? So. So what's out there? The good old LLB. Who's used an LLB? Who wants to use an LLB ever again? Great. That's what I suspected. So some of those worst things we said that you could possibly have in a library, LLBs are like the best at them. They're sticky. You get one big single file, so if I want one thing out of that LLB, doesn't matter, you get the whole LLB, right? So NI says don't use them, despite the fact that we use them prolifically. We say don't use them. But you can use them for distributing plugins, right? So I think that is a valid use case. To be clear, you can have, as a built artifact, LLBs are totally valid, totally a great way to make a plugin, or an okay way to make, not a great, an okay way to make a plugin. They are not a great way of sharing code between developers. Anyone? That doesn't feel controversial, right? Okay, great. LV Lives. Who's used these before? All
That's what we
right.
call them. This is not a library. Let's
Yep.
use the word library correctly.
Yep. Yeah, we're really great at taking general terms and using them for specific things, and then trying to figure out how to hedge our way back out of it after we decide to make two different things that do the same thing. Okay. So the pros of this are we get namespacing, right? So it has some sort of internal structure. We get namespacing. We get private scope. We have really great support in the LabVIEW project. But then we still have a sticky problem, right? Things still, once it's in an LV Live, when you're deploying, maybe you can be a little more intelligent. Maybe it only pulls in the VIs you actually use in the LV Live, but it doesn't change the fact that you have this like two-way dependency, right? Those VIs don't exist independently in this LV Live, and sometimes it's even worse when it does the intelligently pick the VIs you're using, because then you have to explain to someone why there's like 8 yellow exclamation points saying you can't find a VI. And it doesn't matter, it's fine, don't worry about it, but it's still, it's gross to look at, right? How about PPLs? Who's using PPL? Who likes PPLs? All right, that guy. 2 people, okay. I'll tell you what, I have mixed emotions on these. I feel like they're like a jetpack tied to a boulder. They get you pretty far, pretty fast, but when you run out of tether, it's bad news, right? So pros are that you can build LV Lives in development and then swap it out for a PPL. They give you a nice, clean way to share code. You get crazy good performance gains out of them because you're not running just source. They're compiled versions of those VIs. You can even build like debuggable ones so you can still see what's actually happening inside the PPL. Cons are all the same cons of an LV Live. And this con cannot be overstated enough. It's built, right? And it's targeted to a LabVIEW version and a target type. So how many of you guys make something that it goes on more than one version of LabVIEW? You want to make libraries, you can use more than one version of LabVIEW, right? How many of you all target things that go to more than one target type? So RT, FarLap, Windows. Okay. How many of you all really like the n squared property of LLVs? Or I guess it's m times n, not n squared, right? So where m is the number of LabVIEW versions you want to support, and n is the number of target types you want to support. You want to talk about needing to justify to your boss that you should build a build server. PPL is the best way to do it. So, standardize on PPL.
For you who likes build servers in the back.
Yeah. For the guy that likes making build servers, get your company to standardize on PPLs and you'll never be out of the job. Okay, LabVIEW classes. Who's used these? Great. They are literally just a LV Live with some extra features tacked on. All the scripting functions that work on LV Lives also work on classes. You can open it up as a LabVIEW LV Live, and LabVIEW won't skip a beat. So the two things they add are inheritance and dynamic dispatch, which are actually really sweet features for making libraries and plugins and interfaces and everything else.
We have a request for lights to go back on.
Do we know how to operate this thing?
How many LabVIEW developers does it take to turn the lights on?
There you go.
All right, how do we feel about that? Sweet. All right. Okay. How many of you all have seen a library of classes? Do you think it's good? Do you think it's bad?
It's necessary if you want to build in a PPL.
Yeah. What's that?
It's necessary if you want to build it in
Oh,
a
sure.
PPL.
Yeah, you got it. Yeah. So the only time, really, honestly, there's a justification for why you put it inside of a class is that, despite the fact that they're exactly the same under the hood, LabVIEW won't build a class into a PPL. So you have to put that class inside of a library, and it's literally just a container to point the PPL build process in, right?
It also provides namespacing.
Okay. So the class also provides namespacing.
So you get 2 layers of namespacing.
All right,
versus
2
just
layers of
one.
namespacing. Is there such thing as too much of a good thing?
I hope you're only ever doing that to ship artifacts that will run, not for developers.
Yeah,
Because
right. So,
you'll make them very sad.
I think that brings it back to the same point of there are things that you don't do when you're developing libraries for other people to use that you 100% should do when you're building code, right? I feel like that's one of them, right? Having a library of classes in your project that you're building totally makes sense. Gives you both to your point, a logical hierarchy namespace for your project, but it also glues them all together in a way that makes them not super great for distributing and sharing code with other people. Okay, let's talk through some of the actual packaging tools. So this build process or these build artifacts. VI Package Manager, everybody familiar? Anybody not use VI Package Manager? All right, in. That's sweet. Okay, so it takes a bunch of LabVIEW code and it transforms it into some kind of packet that someone can install, package that someone can install. It does recursive dependency resolution, which is pretty nice. You can say my package depends on these 3 other packages, and even these versions of these 3 other packages, and make sure they have at least that version installed. The cons are that it installs them to VI Live or User Live, and it hides code from your project, right? So maybe this is good, maybe it's bad, but the end developer only really gets to see whatever it is you decide to put on a palette, right? So you spend a bunch of time, they can go dig around in VI Live and find it, for sure. But there's not an intuitive place for how you get to this code outside of the LabVIEW palette.
I have huge respect for JKI in doing this. They transformed the LabVIEW community without us sharing code. I think that with the benefit of hindsight, we can start to attack some of the weaknesses here. We can learn from it.
What you got? I see the trouble look on your face.
No, just to be clear, you don't have to install the user lib or VI lib. You can install anywhere you want.
Oh, sure.
So how
If
do
you wanted to
access-
show up in the global search and you wanted to be visible to a developer, I feel like it has to go to one of those 2 locations. Or you can't. How about
search
this?
paths or
How about this? I can't dynamically choose where I want it to install when I'm installing it.
Sure. That's fine.
So maybe it's user lib, maybe it's VI lib, maybe it's the desktop. Doesn't matter. It's still the developer chooses where it gets installed. So yep.
Kind of still add the VI can find to your project. So if I need to reinstall anything on the computer, I just get my product, and that becomes a VM file, and that's all. It's not linked to the VIPM manager. You can just extract the VIPM file from a local cache.
Oh, sure,
and
yeah.
add it to your product.
Yeah, what we're saying is adding the VIPM to your project is a good workaround.
Yep.
Gets you some of that.
Yeah. Okay, so I think that's probably a better way of saying it. Sure, you can install it. It can be installed wherever you want it to. You can install it at arbitrary file locations. But the difference is that it's not dynamic. The end user isn't choosing where that gets installed. So we lose the project by project functionality, right? Short of copying into a directory, and then your instructions are go copy these VIs out of this directory into your project. Anybody touched NI packages yet? All right.
I like them. I like
Yeah.
what NI Package Manager is doing.
I think we're moving in the right direction. Seems like a huge step up from previous options. They have great NI support. For the first time, you can really kind of tag drivers and other NI things as dependencies. You get kind of a one-stop shop for all the NI software and all the external software, which is very, very nice. They support things like system link, so you can package up your artifact that a user needs with everything else, and just say, give me a deployment that's set up to do this, right? And get all the test cases and everything else for whatever you got going. Put it in a package. You can get it off a system link. You can get it off the tool, or not the tools network, whatever we're calling it now, the NI package feed. And they also have recursive dependency resolution. They are still global in scope, right? It still installs to like a directory that the end user can't choose. It does the same project hiding stuff. And here, what I think is hopefully something that we address in the future, but I'm not making any forward-looking statements. Copyright, TM, legal, whatever you got to do here. They're not optimized for distributing things, for distributing VIs, because they don't do mass compile for the LabVIEW version that they're targeted to. So it's just a deployment tool. VI Lab does this nice thing where it goes back and says, you installed it for LabVIEW 2017? Great. I'll run all these things through the LabVIEW 2017 compiler, and now they're ready to go, right? So that's maybe not a big deal for things like LabVIEW, but for things like Veristand, where the plugin year matters, you end up in this like hole where you gotta say like, okay, I have a package for, do I want a package for the plugin, or do I want a package for every year version of this plugin, or do I want a package for every year version of a suite of plugins? And it gets to be like a real rat's nest. So, and
Now some ones that aren't really well known. Who here's heard of GPM? Who here has used GPM? Figured not many people would know about it, so I have a few slides to introduce it. So GPM is a G package manager, and it's modeled after NPM, the node package manager, and it takes a lot of cues from other package managers outside of the LabVIEW world. If you wanted to do a survey of some of those other package managers, you can look at things like NPM, Linux package managers, Python script. There's a lot of cool lessons to be learned out there. We're not going to go into those today. We'll talk about this. So if you go to gpackage.io, you're greeted by this cool web page. Down at the bottom, it tells you how to get GPM. It's distributed as an NI package. If you copy and paste that line in your command line, that's all you need to do. Then you run it. You run the GPM browser, and the first thing it opens is select your project working directory. So you go and select a directory, and once you've selected your project, okay, I'm going to GPM test here. It lets you set it up as a package. If you're going to say have other people on it, you can put your info there and version things. Then, once you set up your package in the scope of your project, you can choose, you can browse. So I hit browse here, and then I search in Digit, and Digit has a couple of packages on there. Not as many as we want yet, but we're getting there. You can choose it, you can select it, download and install, done. Then if I go and look in my folder, there's a GPM packages folder, and if you dig down there a couple of levels, there's my code. And I also have this gpackage.json file that tells me what library it is and where it came from and what version it is. That's cool. It also has a whole publisher page for if you're going to publish one. Helps you put all that together. So in 30-second version, there's more. Check it out. I've tried this. I've tried all these. Pros, it is project scoped. It does the dependency resolution for you. It gives you a manifest file. If you use this, no more, I can't find your VI, good luck figuring out what library it is. If you wanted to level any criticism at it, it's that it's a young project and there's no adoption. Oh, if you look at there, there's only a few packages. That was what I heard when I heard about it at the CLA Summit. So I put some packages on there, because after checking it out, I think this is a great option. You do have to build the packages. It means it's a build chain. So I consider that a con. So that's GPM. You have to be online. No, this can load from the GPM. This has a hosted repo similar to VIPM. You can also load packages from a locally hosted server or a flat file or a couple of other options. So you can host your own private repos.
Well, but only, I guess,
Can you sideload the packages and load them?
Who's the developer?
Who's the developer? Some folks at MGI started it, which they're right across town from us. It's easy to say that they're competitors now, but I think they're doing this right. Let's see. You're in the back and then Chris. Yep, that's you.
Yeah, I was in the introduction for this from More Good Ideas, and he was talking about it, and he said that it wasn't didn't have the capability for private repositories.
It didn't have a private.
So has that changed in the last 24 hours?
That was probably a wrong answer.
Okay. All right. Because immediately.
Do we have some MDA
Yeah.
folks here? Can we answer that? The question is about private repositories and support for that.
Right. I mean, I wish Derek was here. He's in Africa. And he was supposed to give that talk, so.
So it's good.
So,
We talked
you
with
should be
Derek,
good.
and when we spoke with him, we found that there were 3 ways to load packages, and one of them was from a flat file. So we set up a file share, and so it is a work in progress, and there are plans to add even more features. So that's one of the possible criticisms, is that it's young. But hey, it's on GitLab, and you can help make it better. Chris?
Can I list a dependency of a GI package on a non-GI package? And if the answer is no, how do we plan on taking all of the code that's already in existence and porting it to G packages? How
do we get the world onto GPM? That's a wonderful question. I don't know. Derek's not here. I'm not going to be able to answer that. If you can explicitly list, say, dependencies from GI package manager in GPM, there's a great description spot. You can put it in there if you needed to. I would love to port everything over to it. I would love to port everything over to it. I think it may take some time.
Step 1, presentations at NIWeek about G Package Manager.
Yep.
Yeah, I'll just say that, we didn't feel like we had the freedom to convert people's packages over. But I think Derek's got the tool to convert people's packages over. So if you want to say, hey, I want to convert mine, then we have that technology in-house.
So I'm going to poke it stuff to Derek. Okay. Before we jump to any conclusions, there's another option Tanner's going to tell us about besides Gpackage.
All right, who here has seen or used the Git Submodule? Who likes them? Yeah, right? That's how I feel about it too. It's like, really this is the best way except for all the other ways, or the worst way except for all the other ways. Gpackage Manager looks pretty promising. But I'll kind of walk you through what it is, why you might want to use it, and what the pros and cons of it are. So what it basically gives you, one thing that's nice about it is it's a native feature of Git. I don't have to install a tool from Derek's website or from MGI's website. I don't have to install anything really, other than Git, which I'm already installed.
Most of the folks here.
Yeah, sure. I have a traceable copy of an entire repository inside of my working directory, basically, right? And a pointer, basically, in my repository to that code. It comes pre-installed. There is no build process. You literally just put the stuff in Git, and then you go to your other thing and say, hey, I'm also using this stuff in this repository over here, and that's pretty much it. One thing it does give you is a manifest file. There's a little list of here are all the submodules that my project is using, so when someone else pulls this thing down, they know exactly what else they need to pull down, and most tools, like Source Tree, will just automatically pull it down for you. There is an easy transition between a user and a maintainer. I use this a lot when I'm developing, and I think, you know what, I'm starting to realize that I'm building up, this is not really specific to this particular project. It'd be really nice if I made this into some sort of plugin. Usually that means hit the stop button, start moving all that stuff into another project, start worrying about how I'm going to package it, start eating my own dog food of building packages and installing them, and then making sure that my project's pointed at the thing I just made, so I don't end up with this pollution state where the VIs that I want to have in their own project are separate from the VIs that I'm working on, and it ends up in this terrible recursive state. And I find my productivity just drops, and I used to end up just abandoning this idea that I was gonna spin these off. I'll come back to it maybe, but let's get real, we never come back, right? So what I end up doing now is I say, you know what, this should be a separate repository, it should be a separate package. Let me make a directory. I'm just gonna move all that stuff in that directory and say, this is a Git repository and it's a submodule of this repository. Now when I go to commit, if I've made changes to VIs that are part of that submodule, it tells me, whoa, did you know that you changed some of the stuff that you said was a separate thing? And I get this nice processing. Most of the time, especially when we're developing, that's okay, right? But it gives me that nice clean transition between moving from developer to consumer, so that as my plugin is being used in a larger framework and I'm trying to make sure it's separate, I definitely have a much easier entry point to deciding that this part of this project is going to be something that I want to reuse. Cons is that multi-dependency gets really tricky. You can have recursive dependencies, and you can even have recursive dependencies that rely on each other. But and I'm not going to say, what am I trying to say? It doesn't resolve that problem for you. Your Git's going to get really good if you're using this approach, because you're going to have to figure this out yourself.
I think it's made me a better Git user.
Oh yeah.
But it is a tough ramp up for new developers when they start using this. They start getting commit errors. What's going on? And I have to go there.
Yep. RT stuff gets a little tricky, because what ends up happening is that your submodule is pointed at an RT target, and now the binary's changed, and everything's like, whoa, hold on, did you mean to change everything in this entire plugin library? And you probably did not, and you probably actually didn't even do that. But now you're stuck in this purgatory of I have to tell it to ignore these changes, but I'm essentially turning off all the benefits of having this infrastructure in place at all, right? So this is really great, honestly, as a mechanism for getting the code, but now you're going to get a warning every time you try to submit your main repo because your sub-repo changed, even though really, honestly, all it changed was its target type, right? So that's a little hard to get past, and it can be really confusing for new developers who definitely didn't touch your stuff and are still getting 100 warnings about how they changed something, right? And they're like, I don't know what I did. So this is kind of the basics of how you add a submodule. In Source Tree, you basically go up and you say, I want to add a submodule. Here's the submodule I want to add. Here's the local relative path. So you have your root directory. It's just going to basically create a folder, wherever you tell it to from the root, and say dependency A. And so you end up with this these two files. One's the manifest file of all your submodules, and it just says .git modules, submodule, dependency A. Here's the local path for where I'm going to describe dependency A. Then dependency A, you have subproject, commit, and this is where it gets really neat, is that these submodules are actually targeted towards an individual commit. So remember that version 2 versus version 3 problem I talked about earlier? This is resolved here. I don't have to worry about versioning my actual project, because, you should still do versioning. Let me back that statement up. But you get this nice idea that this is a very specific version of this code that I'm using, and only this version, and now all the tooling and all the development tools and all the build tools and everything else are using the same mechanism for resolving them.
They will default stay pinned on that project on that commit until you explicitly change it.
Yep.
And to answer Chris's question, isolating users from the maintainer's churn. If you manage your Git repo well, Git flow is a thing, Google that, and you can have a branch for, hey, here's my releases. You can just watch that. And if you manage that Git repo, this can give it to you without a build process.
Yep, but it never upgrades without you explicitly upgrading it, and it's still on a project-by-project basis, right? So I can move to version 3 for my other project and stay on version 2 for this project, and LabVIEW doesn't know or care. Okay, so this is what it looks like in the repository and on disk. When you go to github.com or to your, whatever your Git provider is, you'll see, depending on your provider. For GitHub, at least, it gives you this nice little like, hey, here's dependency A, and here's the cache of it, or the hash of the commit. And if you click that, it'll actually even take you to the repo, so you can kind of see how it's all structured together. And see, like, from this page, that this project depends on this other thing. And then, but on disk, you get this folder that says dependency A, and inside of that is all the code from dependency A. Packaging your code, there is no packaging, there's no build, there's no nothing. You just put them in a folder and upload it to Git. This gets tricky though, or there's some downsides to this, in that, is that basically you gotta say that we're all in on submodules, and so your G package build or your NI package build or whatever else, if it's in that repository, or your build specification rather, if it's in that repository, it's now in my source code too. Because I can't pick and choose. I'm not cherry picking when I do this. It's give me everything, right?
It's the whole repo.
So you end up with like the documentation, the build specification, any other artifacts that the developer put in their first repo. There may or may not be in their artifacts. They're artifacts in your code now, right? Which is kind of a bummer sometimes. But I usually find that the benefits outweigh the negatives. Okay, so what's the catch? We said it does dependency resolution. If my application depends on A and B, no problem. If A depends on B, maybe there's a problem now. So I can tell it to recursively, most tools will let you recursively resolve dependencies. So A will go get a version of B, and that's all good. And you know what? I feel like sometimes this stuff gets a little like abstract. So I'm going to give a concrete example so we can just all be on the same page, if that makes sense. I'm going to make a web API for my application. I'm going to use this JSON framework. It uses the JSON API, but I'm also going to use the JSON API in my part of it, my glue, right? So what do you think LabVIEW is going to do when this thing has a copy of a bunch of JSON APIs and it's going to load into memory? And this thing also has a bunch of copies of this JSON API. Yeah, it's going to be basically this like cross-link nightmare, right? It's basically
If the project loads it at all.
Yes. Yeah. This is definitely going to be a scenario. Yep.
So just to be clear, we've got two JSON API VIs on disk, different locations. same
Git will
name.
want to put 2 copies on disk. Yeah.
In
Yep.
different locations. Okay.
Yep. Yeah, and they're both being asked to be loaded into memory, right? So you're going to have to resolve this. You're going to have to figure out how to do this. You can get around this. You can do a couple different ways. They all require a substantial level of like Git black magic that is not. I'm not even going to try to describe it to you here, if that makes sense. How about this? Now we're really in trouble, and most of our workarounds definitely don't work anymore. Because the workarounds basically consist of tricking it and pointing to the same location. Except that now I don't want it to point to the same location. I want these two things to be discrete.
To be fair, unless there's namespacing, this is a limitation of LabVIEW.
Right, exactly. We're not fighting JSON problems. We're fighting distributing source problems. And the reason we went with this was to get around some of those problems. But now we're back in the same hole. And we paid the cost of using this relatively low-level tool and gotten none of the benefits. So beware of this. Once again, there's a few ways. Now we're down to the ways around this are best practices, not things that you can resolve for other people, if that makes sense. The right way to do this is to have a JSON API version 2 is namespaced to version 2, and then a version 3 is namespaced separately, right? But that's just you just hoping and praying that the developer decided to think about this use case. So, can we fix it? But only if you're getting really good at Git command line black magic. So to review, it's nice that it's a native feature. It's nice that you're not dependent on anything other than the source control you're already using. It's super great to have traceability. I mean, this is, quite frankly, I think this is the best traceability I've seen. It is explicitly this thing, and if it's not that thing, then you need to confirm that you meant to do that, right? I like that it comes pre-installed. I like there's no build process for when I'm making toolkits. Makes my life a lot easier. I love the manifest file. We definitely have our build server set up to where if there's a .git modules file, it goes and gets that and says, I'm going to go install this version. I'm going to go grab all the stuff, or not even install, right? I'm going to go recursively download all these things too. Easy to transition between user and maintainer.
I think that's one of the best parts.
Yes,
right there.
I mean, I think this is honestly, like, that is the number one benefit of this, is that I can switch between user and developer, or be both at the same time of stuff as I'm getting it off the ground, right? and cons is that multi-dependency becomes this black hole, and it definitely can reach points where there's nothing you're going to do that's going to fix that problem for you. RT targets trigger the scream about something changed no matter what you do, but you will get good at Git. If that's one of your objectives for this year, do it with submodules. You'll get good. Cool. So what's our conclusion?
Get your tomatoes ready. Brief comic interlude before I.
Okay. Ready?
Yeah.
Everybody get the joke? All good?
Okay. If you are sharing code, your user is a developer, don't use any of those other tools. Use Git Submodules or GPM. And if everyone does this, we will have a better tomorrow. That's our conclusion. Does anyone disagree loudly with this? I feel like we've laid the groundwork.
Oh, we got one.
I think he's a contrarian here.
All right. I just, you wanted to know if I disagree. I did.
Oh, okay. Disagree.
Well, until GPM has some further features. The reason why is VIPM still does two things that I think are necessary. One is sometimes you still need to install stuff on the global IDE level. The other thing
Global
is,
installs, GPM doesn't do. Yeah.
So actually I think all the tools are necessary. They're all good for their thing. The other thing that VIPM does that you still need is palettes. Being able to install stuff with palettes is necessary for some things.
And I have a note here on one of these next slides that palettes is what I want as well.
GPM, on the other hand, though, if you are installing for a project, then it's going to show up in QuickStart for you. You don't necessarily need a palette. But some tools that you create, you want to have that in.
I agree with palettes, and that was something that came out of our conversation, and that's an add-on as well. Is we would love to have project scoped palettes, and Tanner found a way to do that with classes, and it's convoluted and it doesn't make a lot of sense, but apparently it can. That's a good question. We'd love to make that a very easy to use feature.
What are you trying to
You use symbolic linking with another tool on top of GPM or in GPM to switch the context of your VI library for transparently to utilize palettes and everything to the project location.
I'm going to sum up. The question is, can you do it with? Can you build it with symbolic links and so on? I'm going to leave this to say I would love for there to be an easier way to get project scope to palettes. And if GPM can solve it, great. If then I can solve it, great. I think that's a good thing we can do better. Quick comment, 10 seconds from Chris here.
I think the pros and cons are dependent on the context of usage. So what you've listed as pros and cons may or may not be true for all of us. I'd be interested in seeing a side-by-side objective characterization of each of these technologies.
Oh, would you?
Right? And so, and the personas. I'm a new user. I'm an architect. I'm an infrastructure developer, and why each of these might be important. The last thing is, I think that all of these technologies should get adopted, and all of the source should be easily exportable in any form. I'd like to be able to abstract away that exporting process if it's required. So now all of us, you can use VIPM if you want. You can use G Package Manager. It doesn't matter. We can all export our source in all forms. That would be nice.
Right. Yeah. So let me say that I think we're getting stuck on this, like which of these package manager things we should use. Quite frankly, if you're using any package manager, I think we've done our job. Like use a package manager, kind of, or some way of managing your distributions, right? I think more what we're getting at is LOBs are not an effective way of sharing code, right? They have their use case. It's not this. I think to your point, I think there's some syntactic sugar that VI Package Manager gives you, and even NI Package Manager gives you that we don't currently have figured out. I think in my mind though, there are things that are missing from VI Package Manager, and there are things that are missing from Submodules and G Package Manager. The difference is the things missing, they're hard limitations of VI Package Manager, and they are manpower limitations of G Package Manager and submodules, right? We got to figure out how to do it, but I feel confident they're technically feasible. So,
2 other categories, cost and open source.
Oh, yeah.
Add those.
Cost and open source. That would be good.
well, listen, Andrew and I are both broke, so we just kind of assumed that all these were free and open source.
Two other comments that came out of questions is, hey, I'm totally on board with GPM, but it doesn't give me namespacing. I'm not going to use it. No. Bite the bullet, put something in an LBlib or a class, and then in something like a submodule or GPM. And you can do it that way. I would love to have a way to do that without some of those sticky strings. That's a future thing. NXG is taking care of some of that. But again, according to our intro, this is where I am today. That's what current limitations are.
So here's what Andrew and I want. We want it to not be sticky. We want it to not have to build it. We want private namespacing. We want private scope. I want namespacing. I want versioning. I have to have a manifest file. I spent ungodly amounts of time just churning on oh, my custom device does something different now because this library I forgot I used in my custom device got upgraded from version 2.5 to 2.6. And even though they claim it wasn't a breaking change, it certainly broke my stuff. I want dependency resolution. I want to be able to add to a LabVIEW project. I want to be able to install different versions at the project level. I want project scope palettes and improved cross-version support. And these last two are ones that we still have to solve.
Cool. Libraries are not LV-libs, they're not LVs. Libraries are libraries. You can call it the Library of Congress now, though.
All right, so check out source tree if you haven't, if you're looking for a good Git client. I would argue that I haven't had a feature that I was trying to do in Git that didn't have a representation somewhere in source tree yet. And all the power user interfaces for Git, this is the one that I feel like I took the least amount of ramp up or learning curve to figure out where to put it. Right?
If you need to do something really black magic, you push one button, you're in the Git terminal in your branch that you were looking at. So.
And new developers, stick to the buttons across the top. Power users, start digging into the menus, basically, right?
Yep.
So.
Yep.
Just in case you forgot about 2 slides ago.
Thanks for coming.